Today we're going to spend some time really thinking about reasoning, and specifically geometric reasoning. First thing we're going to talk about is conditional statements. Conditional statements are cause and effect statements. So one thing determines the outcome of another, and often we see them written as if-then statements. So here are three examples. If the Chicago Bears win, then Mrs. Doll will be happy. The cause is the Chicago Bears winning. The effect is Mrs. Doll being happy. Second one, I will get a stomachache if I eat a whole box of cookies. The cause here is eating a whole box of cookies. The result, I'm getting a stomachache. And the last one, if a polygon is a square, then it has four congruent sides. So the cause or the action is the polygon being a square, and then the result or the effect is it having four congruent sides. Now there are two parts to conditional statement. The hypothesis, often symbolized by a P. This is the cause part, often following the if in a conditional statement. And then the conclusion or the Q, which is the effect of the hypothesis, often following the then in a statement. So let's identify the hypothesis and the conclusion. I want you to pause the video, take a second, and determine what are the hypothesis and the conclusion of each of the statements. Welcome back. So let's see. This first one, the hypothesis, which remember we use a P to symbolize, is the Chicago Bears winning. The effect or the conclusion is Mrs. Doll will be happy. And the second one, the hypothesis, is me eating a whole box of cookies. And then the result or the conclusion is getting a stomachache. And the third one, the polygon is a square, and then the conclusion is it has four congruent sides. So hopefully you were able to identify this. We'll practice these more in class. So now I want you to try writing a conditional statement from the information. Let's look at the first example together. Two vertical angles share a vertex. So the cause is going to be that they're vertical angles, and then the result is they're sharing a vertex. So my example is if two angles are vertical angles, then they share a vertex. I want you to try the next two. Welcome back. Hopefully we got these similar to mine. So the cause is it's Friday, and the results or the conclusion is students dress down. So if it is a Friday, then students will dress down. And you could have reversed this and said students will dress down if it is Friday, but remember we want the first part to be, or the if part is the cause, and then the effect is the after the then. The second one, if school is starting, then it is August. Now, for every conditional statement, we can write a converse, which is the reverse of it. So let's look at the first example. If Chicago Bears win, then Mrs. Doll will be happy. We can reverse that and say, well, if Mrs. Doll is happy, then the Chicago Bears won. Second one, I will get a stomachache if I eat a whole box of cookies. So I can reverse and say, if I get a stomachache, then I eat a whole box of cookies. So it's the opposite or the reverse. I want you guys to try the last one. Hopefully you got, if a polygon has four congruent sides, then it is a square. We're reversing what happens to cause the second thing. Counterexamples are an example which disproves a conditional or a converse. It disproves a claim. So remember the converse we wrote, if Mrs. Doll is happy, then the Chicago Bears won. Well, a counterexample to that, or something that could disprove that, would be Mrs. Doll is happy because she ate chocolate for lunch. Mrs. Doll loves chocolate. So she's happy not because the Bears won, but because she ate chocolate for lunch. And you should be happy there's a counterexample, because we know the Bears haven't had a good season this year, and if Mrs. Doll was only happy when the Bears won, it would be a long year for everybody. So this counterexample actually works in your benefit. Let's look at the second one. Here's here's a converse we wrote. I will get a stomachache if I eat a whole box of cookies. Well, I could also get a stomachache because I have the flu, or I drank too much soda, or I ate something really disgusting or rotten. I mean, there's lots of reasons I could get a stomachache. Just because I have one doesn't mean I ate a whole box of cookies. I want you guys to try and find a counterexample for this last one. If a polygon has 4 congruent sides, then it's a square. Hopefully you came up with a rhombus. A rhombus is a polygon with 4 congruent sides, but it's not a square. So a rhombus would be a counterexample of that claim. Now there are 2 types of reasoning. One is inductive reasoning, and this is reasoning based on patterns you observe. Something you guys use often in your life. So if I said red, blue, red, blue, red, blue, red, hopefully you would answer blue. Based on the pattern you observe, that would be the logical next step. In the conjecture, you made a conjecture. Conjecture is the conclusion reached by using inductive reasoning. So when you guys said blue, you guys used a conjecture. You made a conjecture based on the reasoning. So I want you guys to use inductive reasoning to describe the pattern and find the next 2 terms or figures in the pattern. Hopefully you noticed that in the first example, we're multiplying by 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So my pattern, based on my inductive reasoning, is that I'm multiplying by 3. And so 243 and 729 would be the next logical answers. In the third one, notice we're adding another diameter to divide it into equal pieces. So we're going to add a 4th diameter to divide it into 8 pieces and a 5th diameter to divide it into 10 pieces to continue my pattern. So we have inductive reasoning based on a pattern. And then we have deductive reasoning, which is the process of reasoning logically from given statements or facts to a conclusion. So here's an example. Student A is in geometry. Geometry is an 8th grade gap class. Therefore, student A must be an 8th grade gap student. That's deductive reasoning. I'm making logical statements based off the facts that I have. Now in math, we use deductive reasoning most of the time when we use proofs. And a proof is just a convincing argument which uses deductive reasoning. Actually, you guys have been using proofs when you do your problems of the week. So this isn't a new thought for you. Now we just kind of have a name for it. But just like your problems of the week, you're trying to give logical reasonings for each step you're taking. So we're going to use deductive reasoning to complete this proof. We're given some information. When you have a proof, you're always given information. That's your starting point. And then you have a proof. That's what I need to get to. And in this 2-column proof, there are 2 sets. You have the statements, and then you have your justification, just like our 2-column proof. So, first one, we're going to state AOM and MOC are supplementary. Well, what allows us to say they're supplementary? Hopefully you thought about the linear pair postulate, because our conclusion would be that the linear pair postulate says that if 2 angles are a linear pair, then they're supplementary. So logically, I can conclude these are a linear pair, therefore they're supplementary. Then I'm going to say AOM plus MOC is 180. Well, because I know they're supplementary, I can logically conclude that they're 180 degrees because that's the definition of supplementary angles. Now I'm going to say 2x plus 30 and x is equal to 180. Well, because I know AOM is 2x plus 30 and MOC is x, if I replace them, which would be logical, based on the substitution property, I can claim that they equal to 180. It's logical that I could exchange one common value but for the other, one equal value. Then we say 3x plus 30 is 180. And so what I'm saying is 2x plus x is 3x. I'm combining like terms, which remember that is the substitution property as well. Now, I am subtracting 30 from both sides, so I get 3x equals 150. I can do that logically because of the subtraction property. And lastly, I'm going to conclude that x is 50 because I can say if I divide by the division property on both sides, x is going to be 50. And I do apologize that I have 4 twice in the middle. It should be 4, 5, 6, not 4, 4, 5. You know, as a math teacher, counting is not always my specialty. And that's it for reasoning. We're going to do a lot more practice with deductive and inductive reasoning in class. Hopefully you understood stuff, and if you have any questions, bring them to class. Thanks!